Gentlemen, welcome back. Sneaking into Algebra 2 Goal 3, I had a student email me with some topic requests. The topics we're going to be doing are the ones that are highlighted in purple, and now let's get started. So, negative exponents, there's a couple of things to keep in mind, and you kind of see both the most important things happen when you look at your first pair of topics. First things first, just visually, that's a mess. So what we're going to do is we're going to reorder this and do some matching. So what are our numbers? We have an 8, we have a 6, and we have a 2. So 8 times 6 times 2. Then we have u, and that's it. So u negative 4, u 4. Then we have a y and a y. So that's y to the negative 8th, and then y to the 10th. And then we have, what's left? X and x. So we have x and x to the 7th. Visually, just setting yourself up that way, it makes the numbers themselves make a lot more sense. So what is 8 times 6 times 2? 8 times 6 is 48. 48 times 2 is 96. Now when you're multiplying exponents, that means, so u to the negative 4th and u to the 4, that's going to be addition. So a power times a power means you're taking your exponents and you're adding them. So in this case, what's negative 4 plus 4? 0. Completely cancels out. Over here, negative 8 plus 10, that's positive 2. All right. Next up, x and x to the 7th. So your invisible exponent is going to be 1. So 1 plus 7 is x to the 8th. And that's what you're going to be doing for these. It's a question of organization more than it is any actually difficult math. So let's see here. What are our numbers? We have 2, we have 6, and we have 2. 2 times 6 times 2, okay? Then we have v to the negative 5th, and we have v to the 8th, all right? Then we have w to the negative 8 and w. And then what else do we have? v, w. Then we have u and u. So it will be u to the 5th and u to the negative 6. So again, organization, that's a lot easier. 2 times 6 times 2 is 24. V to the negative 5th times v to the 8th is v to the negative 5 plus 8, which is v to the 3rd. Then w to the negative 8 and w to the 1, so that's negative 8 plus 1, which is w to the negative 7th. And then that is u to the 5th and u to the negative 6, which is going to be u to the 5 minus 6, which is negative 1. Now, here's the problem. Those two pieces are in the wrong spot. I know they're in the wrong spot because their exponents are negative. So what that means now is we have to flip where they are in a fraction bar. So 24 is where it's supposed to, v cubed is where it's supposed to, w to the 7th, and u flip where they are in your fraction bar, okay? Once more, make sure we're comfortable. We have 9, 3, and 2. So 9 times 3 times 2. Y and y, so that's y to the 7 and y, w and w, which is w to the 2, w to the negative 2, then it is x and x, so x to the 6 and x to the negative 9. If you're really observant, you'll notice I'm kind of trying to do different shapes so that I'm keeping track of it and that I don't double count anything by accident. But, you know, some people are lucky and they have highlighters. 9 times 3 times 2, 27 times 2 is 54. Y to the 7th times y to the 1st is y to the 7 plus 1, which is y to the 8th. W to the squared and w to the negative 2. 2 minus 2 is 0, so it cancels. And then it is x to the 6 minus 9, which is x to the negative 3. Beep, 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 beep. Alarm's going off. It's in the wrong spot. 54 y to the 8th over x cubed. And as a reminder, once you flip where it is in the fraction bar, the whole point of doing that is that your exponent becomes positive, which is what the universe wants. So what happens if you now have a power to a power? If you have a power to a power, what's going to be happening is that you are going to be multiplying your exponents. So I'm effectively taking this -3 and I'm distributing it to everything inside. So that's going to be 2 to the -3rd, y to the -6 times -3, which is +18, and then z to the 4 times -3, which is -12. And already I see I have some negative exponents, so I got to fix that. Y is the only one that ended up in the right spot. 2 cubed is 8, and then z to the 12th is going to be our final answer. I promise that's a 12. That's a 12, Ms. Dubois, that's a 12. So we're going to take our exponent and we're going to distribute it to everything inside. So that's 3, -2. B, -2 times -2 is +4. C, 4 times -2 is -8. And I already see some things that are not where they should be. B is where it's supposed to be, so we're not going to move that. 3 squared is 9. C to the 8th. Once more, and hey, for once the universe is nice to us. It gave us a positive exponent. So -2 squared is +4 because a negative times a negative is a positive. B to the 5th squared is B to the 5 times 2, which is 10. C to the -6 times 2 is -12. And for once, there's only one thing that's off, so it will be 4b to the 10th times C over C to the 12th. And that's going to be our final answer. Our next requested topic, this is a DSA question. I believe it is number 17 question mark. What we're going to do, he wants the first 4 terms, so we're going to have a 1, a 2, a 3, and a 4. And then we're going to wait for the computer to catch up. Okay, so what's going to happen is everywhere that there's an n, so there's an n right here, and there's an n right here, those are going to be replaced with our 1, our 2, our 3, our 4. So it will be 2 times 1 over 4 times 1 plus 5. 2 times 1 is 2, 4 times 1 is 4, 4 plus 5 is 9. There's my first term. Now this will be 2 times 2 over 4 times 2 plus 5. So what do we have? 2 times 2 is 4, 4 times 2 is 8, plus 5 is 13. There's the next number. So then we have 2 times 3 over 4 times 3 plus 5. Okay, so 2 times 3 is 6, 4 times 3 is 12, 12 plus 5 is 17. And then we have 2 times 4, which is going to be over 4 times 4 plus 5. So 2 times 4 is 8, 4 times 4 is 16, 16 plus 5 is 21. And there is our setup. Next one, we're going to do it again. We have a 1, a 2, a 3, and a 4. So that'll be 3 to the first power plus 5 over 3 to the first. 3 to the first is 3, 3 plus 5 is 8, and 3 to the first is just 3. Next up, we have 3 squared plus 5 over 3 squared. 3 squared is 9, 9 plus 5 is 14, and 3 squared is 9, okay? Next up, that'll be 3 cubed plus 5 over 3 cubed. Wait for the mouse to catch up. 3 cubed is 3 times 3 times 3, which is 27. 27 plus 5 is 32, and 3 cubed is 27. Then this will be 3 to the 4th plus 5 over 3 to the 4th. 3 to the 4th is 3 times 3 times 3 times 3, which is 81. 81 plus 5 is 86, and 3 to the 4th is 81. And there's our list. I tried to find a screen grab of it, but I couldn't find it. So just as an extra note, when you have -1 to the n, or sometimes they'll do n plus 1, depends on what they give you, what's going to happen is you want to keep track on whether your final exponent is going to be even or odd. So for example, if we have -1 squared, if it's an even number, negative times a negative is positive 1. If you had it cubed, negative 1 times negative 1 times negative 1, that's going to be negative 1. So you want to be careful for this one. Most students tend to get a little bit stuck when they have negative 1 in their exponent, so that's just your FYI. Last one. This one, so you know, it unlocks another finding final amount problem. That is also a DSA question, the same way this one is a DSA question. So this is a DSA question, and also this one is a DSA question, both of them. And you're actually using the same formula for both of them. So watch what happens. It's going to be A, or no, it's not A, it's E. It's, what is it? Principal 1 plus or minus your rate over n, and then this will be n times t. Now, for this specific topic, the one that I got a request on, for this one that I got a request on, the formula does not use one of your variables, but everything else we're going to use. P is your principal, which is basically your starting amount, which is your start. 1 we use every time. Plus or minus deals with whether this is growth or decay. In other words, whether or not it is increasing or decreasing. And then rate is your percent. You have to remember to convert it to a decimal. And then finally, T is your time. I want to let you know 90% of the time it's going to give it to you in years. There's one really awkwardly worded one that I couldn't get a screen grab of it. It also is going to be measured in half-lives. Half-lives. All right. So what's our starting amount? 380,000. 1. The population grows, so that's addition. And then we have 6.25. That's the percent. To convert it to a decimal, it will be 0.0625. And then how many years? 6. And honestly, I'm done. I funnel this into the calculator, and the calculator is going to spit out my answer. For this topic, I'm going to round to the nearest whole number. Now, I don't have access to the Alg graphing calculator, and my computer calculator can't handle the exponents in the same way. So, over here, next one, we have a starting amount of 800. And then the value decreases is subtraction, by 35%. So we're going to take our decimal, move it over 2 places to be 0.35. What will it be after 3 years? Funnel that into the calculator, round to the nearest whole number, and that is going to be your answer. And that is everything for the requested topics that were asked. I know at least 2 of these are in a different video, but having them all in one spot will hopefully be helpful. If you have any other requests, let me know. Send me an email and I will get a video up hopefully within 24 hours. As always, stay happy, stay healthy, stay safe. See you in the next one.